Last one, 52. We've got a beam here and a wall here. We're told it's a uniform beam of length 2 meters. So the weight going down here, we've been told, is 20 newtons. And it's being supported by this wire here, coming down here, and this wire has got length 1 meter, and this angle here is alpha. Now that means that the distance there to there we can do from this right-angled triangle here. This distance here to here is cos alpha times by 1, so just cos alpha. And I'm doing that because we're going to do the moments about this point here. And if we're doing the moments about this point, we need to know the distance there to there at 90 degrees. And the distance there to there is the opposite side of this triangle here. This triangle here, so this distance there is going to be the sine of alpha times by the hypotenuse of this little triangle, which is the cos of alpha. That distance there is sine alpha cos alpha. Replay that again to have a look through it. You go the cos alpha from the big triangle and the sine alpha from the little triangle. There's some tension holding this up in the wire there, T for tension. Let's do moments about A. Moments about A. The distance there to there was 1 and the force there is 20. Minus the force here is T and the distance there to there is sine alpha cos alpha. And that's going to equal 0. Well, the other thing we need is we need to actually have a little bit of trig from our core maths, and we should recognize that one there. We should recognize the formula sine 2 alpha is 2 sine alpha cos alpha. And if we didn't recognize it, we should look at the answer and know that we've got this coming. Now we haven't got the whole thing of that, have we? We haven't got a 2 here. So what we've got here is a half the sine of 2 alpha. And so we've got T times by that equals, let's add that on and just get 20. Times by 2 and divide by sine 2 alpha, and we get the answer we want. And part B is actually just a piece of core maths as well. You're told that T, the tension, is 80. So 80 equals 40 over sine 2 alpha. Times the sine 2 alpha up and divide by 80 gives us that sine 2 alpha is a half. By now you probably know that the inverse sine of a half is 30, and the other answer 180 minus that, so 150. And so the two possible values of alpha are 15 and 75. So there's part A and B. So for part C, we're now looking at the forces here. Let's draw this diagram again now. And all I care about now is that we've got 20 newtons pushing down there. Whoops, can't see that there. And we've got this force here going up like this. And we know that the tension in there is 80. And we know that this angle here is 15 degrees. So we've got a force, this there is pushing up here, that part there, at 80 cos 15. And it's pushing across there at 80 sine 15. And the wall is doing some work. As this is pushing that way, the wall must be pushing out. Now I don't know whether the wall's pushing up or down here. I'm going to guess that it's down. And so we're going to have these two forces here. I'm going to call that one X and that one Y. And really, I'm just going to do my forces. Forces to the right are X. Forces to the left are the 80 sine 15. That equals 0. So I've got my X here is 80 sine 15, which I tapped into the calculator earlier, and I've got 20.7 for that. And then we'll go the forces up. The forces up are 80 cos 15. Down, I've got 20, and down, I've got Y. I'm assuming it's down. I'll add Y to both sides, and I'll get that. If this turned out to be negative, then I would have been wrong and it would have been pushing up, but I still would have done the maths the same. And so that tells me y is going to be, that's 57.27. So now I've got a little bit of trig to do just to finish this off. This bit's quite easy now then. So we've got a triangle here. We've got 20.7 along and 57.27 down. We want to know how long is this? Pythagoras, square it, add square root. So I've got 60.9 newtons. And what's this angle here? Well, the inverse tan of this over this is giving me 70.1 degrees below the horizontal. Now, if this, for part D, it's saying if rather than it being steep like that, it wasn't as quiet, we were using the 75 instead, we were at this sort of angle here, then this angle here would be reducing slowly. And so, I mean, then it might even be pointing up, but we'd actually be reducing the angle to the horizontal as we go.